good executive function task. And can we turn the lights down a little bit just so that we can look at the red spots here? Thank you. And we gave a task, which is the go, no, go in functional imaging. And it's a very simple task. You're asked to press a button every time you see a letter. And if you see the letter X, not to press. So you would think these children may be very impulsive and they were pressing when they were seeing X. Actually, behaviorally, both groups, the PTSD kids and the healthy age and gender match control group, behaviorally didn't do any differently. Which means that if we find differences, these are neurofunctional differences that are not associated with behaving differently, but with some mechanism neuroscientifically going differently neurofunctionally. And what we see is that the controls are activating areas of the brain that they need to activate for this, such as the superior, middle, and inferior part of the frontal cortex, but the control is activating significantly more the middle frontal, meaning the PTSD kids and kids that have post-traumatic stress symptoms, which is the way that we look at it, are not activating the middle frontal area as much. When we do the reverse analysis and see what is the PTSS activating more than the control group, we see not the middle, but the medial prefrontal cortex being activated. The interesting thing about this is that the medial prefrontal cortex is not supposed to be activated on this task at all. It's a region that manages the processing of emotional information. And what further analysis showed to us was that it really was related to their comorbidity and to the presence of anxiety. As Dr. Herringa said, comorbidity is very high in this population, in some samples up to 80%. We also identified the insula, which is very difficult to find. It's very insulated. In the temporal side of the brain here is a cortical region where a lot of interesting information is happening. It receives somatic information, it receives a lot of input, and it has a lot of efferents as well. And we divided our PTSD group, because PTSD can be quite a heterogeneous group, into two groups, those kids that injure themselves versus those that do not. Self-injurious behaviors versus non-self-injurious behavior, and those that had self-injurious behaviors had more activity of the insula. In fact, there was a very direct correlation and strong correlation between total CAP score, PTSD symptoms, and activation of the insula. So what about cortisol? Does cortisol play a role in any of this? Well, when we look at the prefrontal cortex through more specific methods, we saw a decreased left ventral area and left inferior prefrontal gray volumes in kids that have PTSD. But we also found a significantly negative correlation between pre-bedtime cortisol levels and the left ventral PFC. So those kids that had the highest levels at night had the lower volume on the ventral prefrontal cortex. So there might be some insidious effects that cortisol may be doing here. Michael and I didn't find hippocampal volumes when we look at these kids cross-sectionally. But we had a small group that we follow for a year and a half. And actually the cortisol was related to the hippocampal decrease in volume that happened from baseline to the year and a half later, so to that change in hippocampal volume. So we decided to look at the hippocampus in terms of fMRI as well with a memory task, and what we see there is increased activity of the hippocampus in the normal group as compared to the PTSS. So we are seeing that the hippocampus is not as activated when performing a memory task as well, and we can see that in the number of voxels that were activated in the healthy control in comparison to the group with post-traumatic stress symptoms. So both of these tasks, the executive function and the memory task, both of them are cognitive. So the next one is emotional, and it's how kids respond to emotional phases. And we had some findings there. We saw this amygdala early activation when the presentation of angry faces was there. It's interesting. We had hypothesized that we were going to see this with fearful faces, but a lot of these kids had a history of interpersonal violence and physical abuse at home, and their cue, their trigger, was not a fearful face. That's what they experienced. Their trigger, their cue, was actually someone being angry and coming at them, and that's where we see this potential neurofunctional marker of hyperarousability. Now, in terms of adaptability, yes, these children live in environments where it's very important for them to be able to rate their environment and know if they're safe or not. So this hyperarousability can be of a lot of benefit. However, so the hyperarousability maybe doesn't become the target on a psychosocial intervention. But the problem is that they cannot let it go. It's just hyperaroused like all the time. So what they're lacking is the cognitive flexibility to know when to turn it on and when to turn it off. So if they are at a classroom and the classroom becomes very loud and it sounds just like it sounds at home, when there's physical violence and domestic violence, they may run out of the classroom, right? And the kid gets labeled as a behavioral problem. The problem doesn't get looked at within the context of the experience of the child. But the child is doing what the body knows it has helped in the past, which is to get out of there, okay? So cues are important, and I'm saying that and I'm stressing that because it highlights the intervention that we have developed for these kids. Then when we look at those breaks in the prefrontal cortex, what we see is that the breaks are not going on. This is on fearful faces, not on angry faces. But what we see is that the normal control group is really increasing their response, their breaks to the fearful faces, whereas the PTSD group is not. So we are getting somewhere with biological markers. I hope that's what we can get out of this afternoon, in that not only we have all these other potential risk factors, but now we can see that altered levels of cortisol, early amygdala reactivity, diminished prefrontal activity are functions and physiological functions that place the child at risk. Now, these all sounds very negative and very bad, and the kid is, bad things are happening. What I want to do now is I want to invite you to look at the other side of the coin, which is that the areas that we are talking about, the cortical regions of the brain and the limbic areas of the brain, are some of the most plastic. They're complex, but they're some of the most plastic regions of the brain. And if environment can have that detrimental effect that we are talking about, could it be possible then that environment could have the opposite effect? That a good, supportive, understanding environment that addresses the needs of the specific child through personalized, individualized treatment reverses that damage or protects the child from further damage. That's where we're headed. I don't have an answer to that. I would like to say yes, and we're doing the steps towards that. And a lot of what I'm going to present now are, well, the randomized controlled trial of our treatment protocol that happened. So I'll present you the results of that. But the main project, which is a prevention project that we're doing at a school district from K to 8th, targeting 3,500 kids, that I'm just going to show you the design because we don't have those results yet. We just started that a year ago. So excuse me. So what is cue-centered therapy? What I noticed while I was recruiting for these biological studies was that agencies were being very helpful, families were being very helpful, kids were being very altruistic, wanting to help other kids if they could. But there was this sense of we need something else. Whatever we have available to us is not helping in terms of treatment, or it's not helping all kids. And certainly it wasn't my intention to work on something that helps all kids. It's my intention to develop treatments and entice other people to develop more treatments, because I think we need a lot of treatments. I think treatment is going to be very specific to the experiences of the children. And the children that I was working with were children, and continue to work with, are children that if you ask them, tell me about your traumatic event, they look at you like you have two heads. It's like, what are you talking about? Because it's a whole life of adversity. Traumatic events are going to happen while you are in treatment with them. Traumatic events are probably, unfortunately, going to happen after the therapy. So then the best thing we can do for these kids is to equip them to become their own agents of change. And what CCT does is that it does that through education and through knowledge. It teaches them what trauma is, what PTSD is, and it teaches them classical conditioning. And it's really interesting how quickly they get classical conditioning, and they understand that, oh, something that happened around the time of the trauma becomes a cue, and that sometimes is something that's neutral, not something that is threatening. But the body has learned to respond to that cue with that same response, which was adaptive at one point. That's why the body has learned it, but now it's maladaptive. So, in a developmentally appropriate way, we take kids through that education piece. And yes, it does have a strong cognitive behavioral component, but this insight piece is very important. The self-efficacy and self-empowerment piece is equally important. So the children are the ones that identify what the cues are, what the triggers are. They're the ones that, after we teach them that a response is a square that has a physiological reaction, a thought, a behavior, and something that you do, that they can actually develop their own responses. So it's a hybrid of different interventions. Nothing surprising here other than the emphasis on what I just mentioned. We did a randomized controlled trial of some kids, and then it was a waitlist group that eventually also received the treatment and noticed a decrease on PTSD symptoms. The solid line is the group in the treatment. Also, according to kids and according to parents, we also saw anxiety symptoms decrease and PTSD symptoms in general decrease. But I want to show you this big decline here, this big slope, because what's happening here is we're not processing the trauma, we're not doing exposure, we're just telling them what trauma is. We're just telling them what PTSD is, and we're telling how responsive it can be to psychosocial intervention, so you better stick on treatment because it really helps. Now, that can be an order effect too. So we haven't done that study where we combine all the components and see if you had the same decline no matter what you do at the beginning. That's another possibility. But I do believe that just letting people know what they have is not clinically the right thing to do, but ethically is the right thing to do as well. So I wanted to take you through Sammy and his experience and how CCT actually worked for him. Education into PTSD symptoms enabled mom to manage Sammy's nighttime episodes. Despite initial resistance, Sammy found relaxation exercises gave him a sense of control and a feeling of calmness. With support, guidance, and instruction meant to avoid suggestion, Sammy told his story, his narrative. He now felt safe. His sense of security increased further as mom learned not to avoid him. But he also missed his father. He learned that he could have discordant emotions and that he could have more than one emotion. Fear, sadness, and anger are three key emotions that CCT concentrates on. During the aggressive episodes, he felt confused, as in a daze, and his heart rate would accelerate. Sometimes it decelerates in some cases. We were talking about vagal stimulation before. I do believe that trauma may affect differently the sympathetic from the parasympathetic system in some kids, and those kids where the parasympathetic gets more affected may develop a more dissociative type of PTSD rather than an aggressive type. After taking out his feelings on his siblings, he would feel guilty, once again, big predictor for PTSD, guilt and shame. Sammy and his mother were introduced to the concept of traumatic cues, and his father's violence was explored as a fearful event, and cues surrounding this event were most commonly neutral, not good or bad. So Sammy came one day and he said, I think I have a cue. I noticed that when mom comes and she throws the door of the car, I hear that sound, and it sounds just like when Dad used to come in drunk and hit us all. And I get very upset, get physiologically very upset. And so his mom was like, okay, I'll get rid of the car. Let's just get rid of the car. And I'm like, no, there's nothing wrong with the car. We can use the car as a cue. It's going to help us through the exposure process. So his brain had associated those things, right? So when exposed to the cue, an aggressive response would result. Sammy and his mother were taught how responses are characterized by these 4 components of cognition, physical, emotional, and behavior. And kids are invited to start in whatever corner of that square they want. Some kids are very brainy, so they want to start with the thoughts. Other like the relaxation exercises, so they may start with the physical corner and eventually develop new responses. If you change one corner, all the other corners change. So we concentrated in developing some more appropriate responses. Although impossible to identify all pertinent cues, our ability to address some cues helps Sammy make a connection between history and behavior. Kids compartmentalize a lot. They know that something happened, that's the history. They know that they have some feelings about it, and they know what they're doing, but they don't see those things tied together. So he gained, we went through exposure, he gained self-efficacy during this process, his behavior improved, and his PTSD reaction show 5 at the end. So we feel very good that we have something that can help some kids, right? Other interventions need to help other kids, and other interventions need to be developed to still work on another third group of kids. But we also are putting efforts into, well, what if we teach them some of these things early on before they develop PTSD symptoms? So we went to a school district that at one point was the #1 murder capital in the United States. This is East Palo Alto, actually, Ravenswood City School District, and enrolled the children in a curriculum from kindergarten to 8th grade where they receive mindfulness, yoga, physical education, which was taken away before, so physical education is back, nutrition, coping skills. It's like a health class, right? A health and wellness class, and that they're going to get from kindergarten till they are in 3rd grade. And if the data is good, the goal of having the data is to make it sustainable so that they can continue to get it. But all grades are getting it now from K to 8th. We are doing a longitudinal multi-method assessment, and the multi-method is biopsychosocial. It's everything I have presented before, the cortisol, the imaging, but academic data as well, behavioral data as well, and also we're doing polysomnography, looking at the stages of sleep. And I want to go to present that right away. There are a lot of attention problems. This is the cortisol. The interesting thing that we have so far is that cortisol is also correlating with those attention problems. So the more attention problems there are, the lower the cortisol level. So we're looking at the pre-bedtime one. Okay, so, no, I'm sorry, this is the cortisol 15 minutes after waking. We're doing that one separately. So there's some correlation there we still need to investigate. But what we're finding in sleep, and this is very preliminary because we've only done the baseline assessment, and now we're starting to look at post-intervention, is that these kids have a lot of problems with sleep. But the most important one that I'm going to mention is that they have decreased time spent during rapid eye movement. And rapid eye movement has been identified as a critical period for brain development, including hippocampal function and hippocampal consolidation of memories. And if you don't have deep sleep and you don't have REM, you may not be able to encode the experiences of the day, and they may get retrieved emotionally rather than mentally. So we have, in comparison with controls, we really see that they're spending 15.5% of their sleep on REM versus the 25 that the controls are spending, which is the amount of time that one is supposed to spend. But also look at this, and I don't know what this means, but we'll have to keep looking at it. 40% of them have apnea. They actually had a saturation of 89% compared to 97% in the normal group. So I don't know, I cannot tell you at this point if that's linked to obesity, if that's linked to abnormalities, but there's certainly a difference here between those two groups. We do have a control district that is not receiving, we have two control districts that are not receiving the intervention at this time, one with similar SES and adversity issues, and the other one less so that we can look at the effect of that as well. And then we're also going to be doing imaging, looking at emotion, which this figure actually tells us that is doing what it's supposed to do, which is activating the amygdala. And also looking at emotion regulation through this task where we are actually asking kids to reappraise a negative picture. So for example, whatever you're feeling, feel less of that. And then that, in comparison to just looking at an aversive picture, represents for us emotion regulation in this task, so I'll be able to tell you more about that in the future. But I also wanted to introduce you to FNIRS because it's a way to get to the brain in a non-invasive way, in a less invasive way than an MRI. The problem is that you jeopardize, well, you don't jeopardize, you just don't get it. You don't get subcortical data. All the data that you get is cortical, but it does have the advantage that it's real time and that it's portable. So we actually could be getting function while the kids are at school or while they are at a clinic. We are going to be doing FNIRS with the CCT in a before and after study. So I look forward to coming back, telling you more about these results, but in general, these students are highly at risk due to trauma, lack of sleep, and poverty. These factors play out in their academic, physical, and socio-emotional wellness. We're studying these from multiple perspectives, and then we are going to be focusing next year on the impact and effect of the health and wellness program. I thank my team and my collaborators in this project and my funders. Thank you.
Thank you so much, Victor. I've been looking forward to hearing you talk about cue-centered therapy for a while. What a great example of translation when someone is as knowledgeable as Victor is about the processes that should be targeted in a particular intervention and then moving toward large-scale interventions that could even be thought of as primary prevention. So thank you for sharing that. What questions can we annoy Victor with at this point? No one has them. Oh, wait, Brian.
Hey, Victor. Thanks for a great talk. So the sleep apnea numbers are quite stunning. And I guess I'm wondering a little bit more about that. Do you have BMI measures in the kids as well? Do those differ between your two groups?
It's part of the academic data that we're going to get because the schools have a test that they do every year. So we're going to be able to look at that. But the interesting thing is that we've always known that the kids have problems at night and they don't sleep well, but we've always thought about it as a symptom. Now we're thinking, well, it might be a really strong risk factor for PTSD if you cannot process your traumatic experiences because you don't sleep well, because you have altered sleep